things we have discussed. We have discussed about the memory, we have discussed about the processor, we have discussed about the input output. So the basic components, we discussed about the system bus. So that is chapter number 2. In chapter number 3, we have discussed about our Pentium processor, because most of the time we are going to write our assembly language in Pentium processor, right? So that's why we need to know a little bit about Pentium processor, especially the history, and then the different types of registers, and also the memory architecture. Hopefully you remember this one, protected mode memory and real mode memory architecture. Right, so that's what we have discussed in the first time. After the first time, we have discussed chapter number 4, which is where we have started our assembly language coding. So whenever we started our coding, we have started with the statements. Then we have discussed about the data allocation, because for any languages, we need to know about the data allocation, the declaration of the variable, and so many things. So that's why we have done this one here. We also have, that's actually before the vacation, we have done until this, the memory, until the addressing mode, right? We have not discussed maybe these two different types of mode, but we have just briefly discussed. So today we are going to discuss. After that, we are going to discuss about some of the very common assembly language code, like move, exchange, addition, subtraction, this one, if possible, conditional, and that means the loop, conditional, and if possible, the loop. So those are the very basic of any languages, right? Whatever you do, low level or high level. So it is very similar way. If we know this basic thing, we can do most of the coding in future whenever it's needed. I will give you one final project to every one of you to make one project, group-wise, of course. And that to do that project, it will be really helpful if you understand this very basic thing, some arithmetic operation, some exchange, some move, some iteration, some other things. So it's very simple one. So if you know this one, hopefully you can do most of the coding. Okay, so that is chapter number 4. After that, chapter number 5, we're going to discuss very shortly, very briefly. As you can see, it is just less than 10 pages, 6-7 pages only, this whole chapter. So very basic about the procedures and the stack operation for the assembly language. Because we already know the stack operation in the high-level language, now it is in the assembly language, right? And chapter number 6 is also important because it is addressing mode. We also have done some of the addressing mode previously here. Here, some of the addressing mode we have here, but there are some other addressing mode as well. But we are not going to discuss this one because we might not have that much time. And other section also, they don't have that much time to complete this one, addressing mode. There is one reason. Another reason is you are going to learn this addressing mode in your microprocessor course as well. All right? Or if you are doing it, you will learn it very soon, the addressing mode. So it will be overlapping the content. So we are trying to avoid this kind of topics which are, overlapping to each other. So we are trying to avoid this one. Hopefully you will learn this one into the microprocessor course. All right? Then the last topic of this midterm is the 7.2. This one. I had the plan that we are going to discuss some of the flag as well, because we need this flag for these topics. But some of the flags you already know. Do you remember the status flag? Yeah, do you remember the status flag? Anyone? Flag? Remember, there are some register in Pentium processor where we have 3 types of flag. Forget it? In control register.
Yes. Yes.
In control register, remember we have the flag and E flag. So that flags, we have three different types of flag. Remember, status flag, control flag,
System flag.
yeah, and system flag. So these are the flags. These are the sum of the flag, like carry flag, zero flag, overflow, sign flag, parity flag. So these flags are very common, and it is very common. You also at the same time you're also going to learn this one into microprocessor course as well. So it's very common. You have already know some of it in that chapter number 3. So you will have a little bit idea why we need these flags, because whenever you are going to do multiplication or whenever you are going to do the division, we need some of those flags. For example, whenever you do multiplication, you have some carry. In that case, you have some carry flag. For doing a multiplication, sometimes the result of the multiplication is bigger than the size of the register. In that case, you have the overflow flag. Sometimes you are doing multiplication or division in the positive or the negative number. In that case, you have the sign flag. Right. So different types of flag gives you different types of status whenever you do different types of activity. Right? And it is happening. It is happening whenever you do the coding. All right. Generally, whenever you do this kind of system level or hardware programming or low level programming, you have to consider all these kind of flags, because by using the flag, you can easily identify the number, you can identify the result or the status of the action. Okay. And it is really helpful. It will be really helpful in the future whenever you're going to, let's say you are a software engineer and your company wants to develop a system software for a new printer, or you are working on a company who are actually based on the IoT-based company, their business is mainly IoT. So if they have a new device based on the IoT, you need to write code for that IoT device. You to know this kind of language. Similarly, syntax is different, but the concept is writing the code for an IoT device, or writing a code for a let's say a robot, all right, or for any embedded system. The basic structure of the programming is the similar as the assembly language what we are learning now. Maybe the syntax is different, because if you're using Raspberry Pi, there's a different types of microcontroller. If you're using the Raspberry Pi, it's a little bit different types of coding, but the basic is same. If you're using Arduino, different types of syntax, but the basic programming is same. Same as what we are actually learning. So the basic programming concept is same. Syntax is different. It's like if you know object-oriented programming, if you know how to do or how to write an object-oriented programming, you can write it in any languages. Right. So if you know the structured language, you actually can write in any language. It's just syntax is different. Like the C or the Python or whatever language you have. I don't know. I don't have that much knowledge about programming. But the structured program, if you know how to do the code, if you just change the syntax, because learning the syntax is one big job. If you have good understanding about the programming, learning the syntax is very simple job. All right, so it's the same thing. If you know how to do coding in assembly language or low-level language coding, if you have that basic knowledge about whenever you want to do any low-level language, doesn't matter in the future which platform you're doing to go coding. Either you can do a coding for your system software for the new device, let's say for a printer, a scanner, or any other device, or maybe a new code for your newly launched robot, or maybe an embedded system, or maybe a sensor network, or maybe anything else. All right. So that is the same thing as well. So please do not think that assembly language is a waste of time and you just need to do the graduation. Not really. It will help you. Definitely, it will help you in your future life. And as I told you before, you never know that where you can get a job. and what will be required in the future. So you should be well prepared, right, for your future career as well. So please learn this course or learn something from this course so that you can use it in the future as well. I know previously, because I heard from the alumni that most of them, they don't want to do they say that they don't need assembly language. They say, most of them, they say, we should remove the assembly language course. Do you know what is the reason they say that they don't need assembly language course? The reason is whatever they have learned in the assembly language in their real life, they didn't, able to implement whatever they have learned from the assembly language course. So they said they don't need it. If you don't know how to use your knowledge or how to use your skill in your real life, you will feel that, okay, that is a wastage of time. Most of the time, what actually students did and doing is just memorize previously and now as well. Now and previous student, what actually you are doing, just memorize something, especially this course, memorize, write something on the exam paper by doing anything, get marks and forget everything. Forget everything about this course. And whenever you are senior, let's say you have a career, if I ask you that which course you think that you don't need, you say the same language. Because he didn't read it properly, because he didn't study properly, because he didn't know that what actually I'm studying in future, where I can use it. You never think about it. And then whenever you are an alumni, whenever you have a job, and without thinking everything, you say that we don't need assembly language without knowing anything. It's actually contradictory, right? Contradictory with yourself. So my suggestion, that is a real life example. That is a real life example. That you don't want to study, you just study for the marks, and after 5-10 years, you say that, okay, I don't need assembly language, because you don't know how to use it. Because you don't know where to use it. That is the problem. So the suggestion is, please, you memorize something, no problem. You do it for the marks, no problem at all. I also did the same. But at the same time, I also need to know, yes, I want to have a good grade. At the same time, parallelly, I want to learn something, and I know, or I guess, or I have a plan, or I have something that, okay, I might use this one in the future in this. So in the future, if I face this kind of problem, then I can use this skill. Like that. All right. Similar, very, 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 very similar like your other programming language. So you never know in the future what new programming language will come. For example, when I was a student, there was no like new language which is very, very new, like Python. I never heard of it. It's very new because we have started at 2002, 3, 4. At that time, there was no Python. But what is the good thing is, whenever the new Python comes, whenever you see that, okay, it's so easy language. Super easy. Because we have some little bit of knowledge, coding, or whatever the new language becomes, doesn't matter to us because we know the basic thing. It will take like 1 week, 2 weeks, maximum 1 month to be the master of that. Because we have that basic. Similar as you as well. If you have the basics, not only this course, your entire graduation, if you have that strong basics, in the future, whatever you face, new language, new technology, new tools, anything, you will be well prepared. And you say, okay, no problem, give me 1 week or give me 1 month, I will be master of that. That confidence you should have like this. Whenever you have a basic, strong basics during your graduation, and the graduation is actually building your basics. Very similar to whenever someone is trying to build a building, right? I think you know that you have to dig a lot underneath the ground to make the base. The stronger the base is of that building, the more higher the building can go up. And the more it has strength to from actually any other kind of disaster like storm, earthquake, and everything. If the base is strong of any building, you can go up and you actually are stronger than anyone else. But if your base is weak, obviously you have disaster. Undergrad or undergraduation level is actually building that base of like the building. The more you stronger you actually make your base, right? You can go more, higher position in your life. Think about it and it will be much more easier for you. So if, let's say, now, because it is now building your building your basics, right? So now actually you don't care about anything and you don't study properly. What will happen? Your base will be very weak. So you cannot go very, higher position in the future. If you have any other thing, like you have parents somewhere, or if you have any family background by which you can go higher, that is different case. But with your quality, with your own quality, if you want to go higher, you cannot go a higher position because your base is very weak. So please, all the discussion, the bottom line is, during your entire graduation, think about it that you are building your base. If your base is weak, obviously in the future you cannot expect that you go very higher position. If your basic is strong, in the future, whatever happens, whatever comes to you, like 5G, 6G, 7G, 8G, or new technology, AR, VR, whatever it is, or completely new languages, and your boss will ask you, okay, this is the new languages, I will give you 1 week, give me something. You have that confidence. It doesn't matter. I know already how to do coding. I just need to know syntax. So you should know what we need to do. Anyway, lot of discussion. Anyway, hopefully you understand what actually I'm trying to say. Because most of the time I heard that assembly language, actually we don't need assembly language. It is boring course. Of course it is boring course. And we don't need it and we don't need to include it into the curriculum. Actually, partially we are actually integrated this course with the microprocessor course. Because as you can see, most of the part is actually related to microprocessor. So we are going to do side by side with an lab. So in the next year, inshallah, we are going to do this course with microprocessor course with a lab course, with a lab, 2 hours lab. So it will be much more better than this semester. Okay, a lot of talking. That is my bad habit. Let us continue with our study. I think can you remember what was the last thing we have done? I think it's a memory addressing mode, right? Maybe. Anyone? Can you remember?
Yes, addressing.
Okay, I think it's addressing. So let me just do a little bit revision. Hopefully you remember all this. One more thing to remind you that compared to the 3 other sections, your result is a lot less, not that much good compared to the other 2 sections. So please, just 1 minute, I can give you a very comparative. For section A, I can show you my, so in section A, their average marks is 65.4. Section B, your one is, let me see, section C. You are section C, right?
Yes, sir.
Yes, sir.
C is actually a disaster. Your average mark is 46. Section A got average marks is 65.4. I have not calculated section B. Let me just give me 1 minute to write one quote. Call average. I'm just using an Excel file. So it takes 30 seconds. Yes. Section A, their average mark is 52 first term. So you can actually imagine section A is 65.4, section B 52, 52 or more than that actually, because one of them got 0, why it is 0. And the section C, your one, unfortunately, is 46. You can imagine that how bad it is. The marks are like 20, 22, 42, 39, 28, 65. Highest marks is 77. No, sorry, 87. 87, it is the highest marks, it is Raqibul Hassan. He got this highest mark 87, rest of you like 60, 70, 40, 20, 30. So it's actually a disaster, especially your section. Because as you can see that comparatively you have a less average marks. So my suggestion is you might have some problem. I don't know what is the problem. My lecture, my materials and everything is same for all 3 sections, everything same. Then why you have that less mark? I actually don't have any idea. So please make sure this is the 20% marks you already lost. You have another 20% marks is coming for the midterm. All right, so altogether is 40% marks. So you already lost 20% marks in the first term because you have very poor marks, very, very poor marks. So you have second chance, which is the midterm exam, which is 20% marks. So please pay more attention, give more attention during the class, interact with me, study, either group study or self-study, or you can ask me or whatever way you actually feel is good. Please study, all right? Otherwise, your marks will be really, really poor. I'm sorry to say that I am trying to give my everything, but you are not actually trying. The problem is if you're not trying, how can I help you? How can I give you marks? If you don't write it correctly, if you make mistake, how I can give you marks? I know you're expecting 100 out of 100, all of you, but expectation and the reality is not same. All right, I want to give you 100 out of 100, but the problem is you have to write correctly into the exam. You didn't write it correctly. That is the problem. So if in your section someone got 87, in your section, same section, why the most of you got 20, 30, 40, 50? That means he got it right, you got it wrong. Same question, same thing, same section. So please, it is not impossible, it is still possible. Please pay more attention. If you have time, if you have any problem, any issues, let me know. I will try to solve it. I will repeat it. Or if you think that the way I am going to give the lecture is really not convenient for you, don't understand anything, let me know. The problem is you don't give me any feedback. No feedback. Nobody says that, sir, we don't understand. Sir, please do this way. It might be helpful. Remember, I'm not a rude person, by the way. I know that you are thinking that I'm rude. I'm not rude, actually. So I don't know why you are afraid of talking with me, because I'm really helpful. If it is logical, of course it is helpful. If you say in this way that the way it is actually it is difficult for us to understand, of course I will listen and I will change the way I will do the lecturing. I always ask you, do you have any question? Do you have any issue? Nobody tells me anything. So if you think that I'm running very fast, if you think that the content are very difficult, if you think that some of the part is really, really difficult to understand, please let me know. All right, please let me know, because the content we are discussing is very, very, very basics. If you are a little bit attentive, I don't think that it is impossible to understand during the class, although it's an online class. Super easy. You just need to do a little bit more attention and you just need to do a little bit of study at home. That is what it requires. Nothing else. Trust me, nothing else. All of your merit, your talent is similar. The problem is who got 87, he give more time on this to study. Who got 20, 30, you give less time. Who got 20 or 30, if you give more time or more attention, you will also get 80, 90. Same. So please, and as I said, all of you are saying, you just need to give more time. You just need to do a little bit more study. That's it. That's what you need. Nothing else. Because the content is super easy. As far as I know, that is super easy. Nothing difficult. What do you think? Do you think the content, whatever we have discussed so far, it is difficult to understand? What do you think? Anyone? How do for example, do you discuss, for example, simple table, the way I have discussed this, do you think that it's quite impossible to understand that how we can make a simple table? No. So if it is not impossible to understand, it's easy, and the book is also very, very much easy to write. And is to give and a little bit of attention. That's it. Chapter number 4 is about the data allocation. So we have done that, how we have defined the data, very similar to the other high-level language, that how we can define the data. We know that there are 5 different types of data allocation, or types of the data. We have DB, DW, DD, DQ, and DT. That means by word, some range, very, very similar to the high-level language. So they have like, if byte means 2 to the power 8, so obviously always it is 2 to the power 8 minus 1. Positive one, and the negative one, we know that it will be half of it, because we have 2 to the power 7, because we need more space for doing this negative number, because we need 1 bit for the sign bit. That's why we have less number of bits. That's why it's 2 to the power 7. Same as the other one. 2 to the power 16 we have, but for the negative number we have 2 to the power 15, because we have 1 bit for the negative sign. So the same as always. So it actually don't need to remember. If you just understand how actually it works, if you know the logic behind it, no need to memorize. So that is our different types of data. Very similar to the high-level language. We can also can remember that we can do multiple definition. That means multiple data allocation, like this way. And we know that our assembler, I think you know that in between the assembly language code, that means this one, and into the machine language, which is 1010 or hexadecimal number. So in between these two, there is one software which transfer or which translate the assembly language into the machine language. Because machine, that means our processor, doesn't understand the assembly language. It only understands the machine language. So whenever you transfer it, right, we need an assembler, a translator or interpreter, whatever it is. So we have an assembler to translate this assembly language into the machine language. So the assembler does a very good thing whenever you define this kind of data, because it defines the memory serially into the memory location, main memory. It's not like random location. It's serially. And it has a good effect that whenever we are trying to make a symbol table, because we know that whenever we define these types of data in assembly language, the assembler make a table for the processor, and this table is called this symbol table for the processor, so that the processor can find the data very easily. So we have the name of the name of the variable and also the offset value. Hopefully you also remember the offset value and how we can calculate. It depends on how long or how big the number is for each of the variable. Based on that, we calculate this offset value. And by using this offset value, the processor can easily find the variable location in the memory. That's why it is faster. Otherwise, if there is no symbol table, what will happen? The processor needs to search or looking for every bit of or every byte of memory in the whole memory location. That will be time consuming. That's why we have a symbol table. So that we have discussed so far. After that, we have discussed that there are 4 different space we have to store our operands. I think you know what this operands means. Operands means if you want to do some operation, for example, you want to add 2 numbers. 2 numbers we have, that those are the operands. So we know that whenever you write an assembly language code, so in this code of the assembly language is actually saved into the code portion of the memory, right? And the data of that variable or the operands is actually stored into the data location. Right, so based on these locations where actually you save your operands, we have 4 different locations, right? First of all, of course, it is the register, then the instruction cell, because sometimes you can find the value of the variable inside the instruction. So that is the instruction itself, obviously the main memory, and sometimes it is input output. In this chapter number 4, we are going to discuss the first 3. That means the register, the instruction, and the main memory. This input output you are going to discuss in the chapter number, as it is written, chapter number 15, whenever we discuss input output. So let us see, we already know that in the register addressing mode, so it is called register addressing mode. That means the operands or the value of the variable is stored into the register. And we know that it's very fast because it's inside the processor, like this. We are moving the value inside the EBX to the location of the EAX register. We know that these 2 are the data register of the Pentium processor. So register addressing mode is very fast, and it will give you the fastest and most efficient way you can get feedback, right? But the question is, if it is most efficient, why we don't use it every time? Because we have very limited number of register. Very, very, very limited number of register, and it's very, very expensive. It's not like that, okay, we can increase the number of register. Yes, you can increase the register number inside the processor, but the costing and the price of the processor will be very much higher. I think I told you the processor I'm using, if I want to have 100 kilo more cache 1, I need to spend 10,000 taka more. Same processor, same thing, but 100 kilo more level 1 cache. So it is that much expensive, right? So it is not possible that you do everything into the register, because register we have very, very short amount of register. That is the problem. So when we use the register addressing mode, whenever it is possible, whenever it is free, and some of the registers are very specific responsibility. If you remember, there are 4 different types of register we have discussed, like segment register, control register, right? So pointer register. So different register have different responsibility. So those register will do those kind of responsibility. That's why we cannot use all the register for every time. Okay, that is the reason. The next one we have discussed about immediate addressing mode. We know that as I have just said earlier, that our code is in the memory of the code segment, but our data, like for example, this one is actually into the data segment. But if you have the data inside the instruction like this, then whenever you try to implement this by the processor doesn't need to go to the data segment of the memory to get the value of this, because it is already into the code segment. It is already inside the code, so you don't need to go to somewhere else. For example, if you write move AL, BL, so then what will happen? The processor needs to go to the data segment to get the value of BL, and then it will move it to AL. Right? Do you understand? If it is instead of 75, if it is BL, and if you want to do the move, so the processor needs to go to access to the BL, so it needs to go to the somewhere else to the memory where the value of BL is stored, and then you get the value, and then we have this move, but it is already on my connection every time. Anyway, okay, I hope you can hear me properly, right?
Yes, sir.
Yes, sir.
So as I said, reason behind this, we cannot use the immediate address mode because it can change. So that's why it is not a good idea that we always write in this way. So when we can use it if is there any option where this value will never change. If there is anything happen like that, or if there is any value like that, then in that case we can use it, no problem. But if the value may change in the future, we cannot use it because we have to write this code again, which is not a good idea. So that's why immediate addressing mode also cannot be used everywhere. So let us see the other options. We have memory addressing mode. We have discussed, the last time, that we have two types of addressing mode, the direct addressing mode and indirect addressing mode. So in the direct addressing mode, we know that we need two components. Of course, the segment address, the base address of the segment, and also the offset value by which we can identify any location of any memory. We had this compared to other one, but the problem is it has some limitations. What is the limitations? If you have single variable, if you have multiple variable like this, and if you have multiple variable like this, right? If you define, then we cannot access the second, third, fourth, or the rest of the elements. We can only access in the first element, nothing else. So if you have multiple one, then in that case you have some problem. For example, we have these two multiple definition, right? Because this is a number like 20 values, and this is a 7 byte for this one, because each of the character, we have 7 characters here. If we want to change the second, third, fourth, or any other value, we cannot. We only can change the first one. Same as here in the table 1. If you want to change the second, third, fourth elements, we cannot do that. We only can access to the first element like this. Look, move. This is a value. This is the variable, and we can have only the first character. Same as this one. We cannot go to the second, third, or fourth option or element. That is the limitations. So to solve this one, we have another addressing mode, which is called indirect addressing mode, right? In this indirect addressing mode, we can solve the problem. Previously, we have here that we cannot access to the second or third position. Here, we can solve this position. We can solve that problem. How we solve the problem? The basic thing is we are going to save. For example, we have an array. Let's consider this is our array. Then we have some blocks, right? Like for the zero number, first number, second number, third number, fourth number. So we have this block. So whenever we have this block, the initial block or the initial memory location of that entire array will be saved into the separate register. That is called pointer register. Oh, this is called as a pointer. This is act as a pointer register. Okay. Let me show you if I have. Picture or images. It will be better if I can show you the images, otherwise that won't. Let's see this one. For example, for the indirect address mode, we have, I think we have discussed elaborately about the, this indirect address mode previous class, right? That how we can access to the second number. No?
No, sir.
All right, so just give you some hints. For example, we have defined this array. So to have 20 values we have, and each of the value is which type? D type. D type is double word type, right? Double word type. Whenever we have a word here, that it has 4 bytes long, right? 4 bytes long. For example, 3. So until this position, just for example, until this position, that is number 1. So when the second number will start, that is the first number. That means 0th number, because you know this array starts from 0. So this array, I mean, for example, this array will start from 0. So, and each of the value has 4 bytes. That means 0, 1, 2, 3. So this is the first number, 4 bytes. So when the second number will start from the 4th position, right? From the 4th byte, right? So if we can change the pointer, because I told you that we need to save the initial memory location of, for example, this is our entire array or this table 1. And we have to store or save the initial memory location, that is the starting memory location, we need to store it in the separate register. It's like a pointer register. So if we change, or if we can change the address of this pointer from here to here, then we can easily access to the next value of that array. That's what we have done. Look, very simply, a very simple way. For example, I think another thing I just need to remember, one thing we have to consider that whenever we move address, we just don't use any third bracket. For example, we want to copy the value inside the response variable. That's why you have third bracket. If we want to copy the address of table 1 into the ABX, then we don't have any third bracket. Right? That's why to copy the address of the table 1 into ABX register. This one, if we want to move the value, then we should use the third bracket. So just keep in mind. So let's say, for example, the first one, as we said, that we need to.
Sir, we have only 4 minutes left.
Yeah. Last minute. Give me just 1 minute. So whenever we try to, as I said, that we need to store the first memory location, address memory location, into one register, and that's how we can store the memory location into the EBX. EBX is our pointer register. That means we are copy the value, the address of the table 1, first address of the table 1 into the EBX register, right? And then we move the value, this is the value, to the EBX register. Remember, the third bracket, that means the value of the EBX register. Then we add the value of 4, because each of the value is actually 4 bytes. So if you change or add the 4 to the previous address, then now the pointer is now here. The pointer is now here. That's why we have added the address, and then we can use the second value. Remember, this is the first value, that's why it's 0. that is the second value, that's why it's 1. So in this indirect addressing mode, we can easily access to other value rather than the first value. Previously, here we cannot do that. Here we only have this first address or first location we can access. Second, third, fourth we cannot access. But in indirect addressing mode, by this way, we can access any other value. If you add 8, what will happen? For example, if we add 8 here, what will happen? It will be
Third.
It will be the third element. Very good, correct. That means it will be the third value. So if you want to go to the third position, you just need to add 8. Similar, right? Hopefully you understand. We will discuss it a little bit more. Right? We can so many times today as well about that. Let me give you the attendance. Any question, by the way? Okay. Give you the attendance.
Hello, sir.
Yes.
Sir, Genie actor, he was disconnected and joined
Yeah.
paper. Trying to join now.
Yeah, okay. You are section C. We have started at 110. Genia. Okay. So CSC 197 section C, please respond Shakil Ahmed. Minur Rahman.
Present, sir.
Saidul Islam.
Yes, sir.